Assalamualaikum warahmatullahi wabarakatuh. So this is a discussion Chemcare module, Chemistry 2 SK025, chapter Benzene and its derivative for stage 1. Let us look question number 1. So question number 1, draw the structural formula of compound A to J in the following reaction. So we start with question A. So benzene react with Cl2 in the presence of FeCl3, which is the name of the reaction is halogenation. Type of reaction for benzene for this one is electrophilic aromatic substitution. So at benzene we have one hydrogen, so one of hydrogen at the benzene will be substituted with one of the chlorine. Therefore, you will produce the chlorobenzene for structure A. Structure B, equation B. So the reaction between benzene and 2-bromopropane. So reaction with also the Lewis acid catalyst. Name of this reaction is Friedel-Crafts acylation. So Friedel-Crafts acylation, kita akan potong pada bromine ataupun potong pada halogen. So this one is electrophilic aromatic substitution. Ingat, di mana kita potong, di situ kita akan sambung. So you potong pada bromine and then potong bromine jumpa CH. So this carbon CH that will be attached to your benzene. So this CH and CH3. So you produce here is actually isopropyl benzene. Okay, question C. Reaction benzene with concentrated HNO3, concentrated H2SO4, temperature 50 to 55 degrees Celsius. So this reaction is nitration. So reaction of nitration, you have your electrophile here will be NO2+. So NO2+ will be replace the hydrogen or substitute the hydrogen. So you will produce a nitrobenzene. So each of the structure will give you 1 mark. Question D. Okay, question D is a Friedel-Crafts acylation. So given to you is the acyl chloride. So again, you're going to substitute the hydrogen that we have at the benzene. So we cut between the acyl group C double bond O and Cl. So kita potong pada Cl. Di mana kita potong, sambungannya itu kita akan letakkan pada benzene. So you will produce C double bond O CH2 CH3. Be careful with the number of carbon. Question E. So the reaction here, it's already have the alkyl at benzene. So when you have the substituent at alkyl, you already have the substituent at alkyl. So you need to look what type of director that we have here. Because we need to proceed with the second reaction. So the second reaction nak masuk pada carbon yang mana. So we need to look at the substituent that we have at the benzene. What type of director. So in this case, we have toluene. So toluene. And we have the substituent here is methyl, which is alkyl group. So alkyl group or symbol is R, auto para director. So it's auto para director. Chlorine, which is undergo halogenation here, will be substituted at position auto and position para. Position auto is 1, 2 and position para is 1, 4. Therefore, chlorine, the first structure will be substitute at carbon number 2 and then the E that we want, the question want. So answer is already given to you at position number 4, which is para position. Therefore, we know that the answer for E will be at second carbon or position number 2. Okay, F. Again, reaction of toluene. Reaction of toluene with Cl2UV. This one is free radical substitution. Free radical substitution. So, free radical substitution will be occur at your side chain also. So side chain at your CH3. So one of the hydrogen will be substitute with chlorine. So you will produce benzene as maintained. And then the change is one of the hydrogen be substituted with chlorine. So what you produce here is actually the benzyl chloride. Each of the structure will give you 1 mark, 1 mark. Okay, next one. Question G. So question G, again, toluene undergo oxidation with KMnO4 H plus heat. So undergo oxidation, the side chain of benzene or the alkyl benzene only can undergo the oxidation when you have the benzylic hydrogen. Okay, add carbon, benzylic hydrogen. So you have one carbon that are directly attached to benzene, and then at that carbon you have the hydrogen. We call as a benzylic hydrogen. You have the benzylic hydrogen, then it can undergo oxidation. So you will produce benzoic acid. Okay, you will produce the benzoic acid. Okay, it doesn't matter how many carbon you have at your side chain. Tak kisah berapa banyak carbon kita ada pada side chain. Yang penting ada benzylic hydrogen, then undergo oxidation will produce benzoic acid. Okay, H. Again, it already have the substituent at the benzene, which is your bromobenzene. Then the second reaction is halogenation with chlorine. So we need to look at the halogen, what type of director. So halogen is also auto-para director, but it's deactivator. Auto-para director. Therefore, product first given to you is at auto position. Therefore, structure for H will be at para position, which is the chlorine be substitute at carbon number 4. Okay, I. Also, we need to look at the director, what type of director that we have here, because the benzene already have the substituent here. So, COOH or the carboxyl. Here is also the, this one is meta director. What type of director? Actually, you can refer to your notes. Already be given to you the listed, the director or the element or the species or the substituent, what type of auto-para, is it activator or is it deactivator? So in this case, COOH is meta-director. Therefore, you have here is Friedel-Crafts alkylation. So Friedel-Crafts alkylation, again, we're going to cut at the halogen, potong pada bromine, and then yang akan masuk pada position carbon number 3 will be your CH, the center carbon. So CH and then CH3, CH3. So position is 1, 3, which is the meta position. Okay, each of the structure will give you 1 mark, 1 mark, and 1 mark. Okay, next one. You have the NO2, nitrobenzene, attached to your benzene ring. So again, you need to look at the type of director for NO2. So NO2 is also the meta director. So when it's meta director, here you have is Friedel-Crafts acylation. So Friedel-Crafts acylation, you cut between C double bond O and Cl. So di mana kita potong, di situ kita akan sambungkan pada hydrogen. We change the position of hydrogen with C double bond O, CH2, CH3. So at which position? So we already analysed just now is meta director. So since meta director, kita akan masuk pada position carbon number 3. So structure will give you 1 mark. Okay. Question number 2. Based on the following reaction, so given to you is halogenation. So the presence of bromine and the Lewis acid catalyst FeBr3 will produce A. So question A, draw the structural formula of A and then propose the mechanism for the formation of A. So we give the product for A. A will produce the bromobenzene. Again, at the benzene here, actually you have 1 hydrogen or you have 6 hydrogen. So one of the hydrogen will be substitute with bromine. So you produce the bromobenzene. Now for question B, we need to show the mechanism formation of A. So mechanism for benzene, we have 3 steps. So each of the mechanism, we give you 3 steps. Semua sama. stepnya 3, cuma pada formation of electrophile yang biasanya membezakan untuk 3 mekanisme yang kita perlu tahu untuk benzene, which is the first one is halogenation, the second one is nitration, the third one will be the Friedel-Crafts acylation. So for this question, we look at the halogenation. So we start with step number 1, formation of electrophile. Formation of electrophile, bromine will be combined with FeBr3 to form Lewis acid base complex. So the arrow will be from bromine to FeBr3, bromine to FeBr3, and then you will produce the complex. Okay, so bromine, you have a positive charge, and then your FeBr3, you have a negative charge. So each, the first step will give you 1 mark, and formation of the complex will give you another 1 mark. Okay, step 2. Step 2 is formation of uranium ion. So formation of uranium ion, the Lewis acid base complex just now that you form the Lewis acid base complex, will be attack benzene to form the uranium ion. Therefore, your arrow should be from pi bond of benzene, daripada dalam ya, pi bond dia. Okay, and then go to bromine, and then bond of between the bromine go to bromine, Br+. Okay, therefore you form the uranium ion. Okay, you should have 3 uranium ion, and you should have the bromine that we substitute just now with 1 of the hydrogen. And then next, don't forget to write your byproduct here, FeBr4 minus actually, but we try to write in form of this because later at step 3 we're going to use back this FeBr4 minus for the next step. Okay, so let us complete the uranium ion here. Don't forget the uranium ion, you should have a plus here, which is your carbocation ion in the uranium ion. And then in the uranium ion, we have to show the arrow. So the arrow movement of the electron from bond to bond. Then you have the change the position of double bond, and also you have the change position of carbocation ion here. Next one, the movement of electron from bond to your carbocation ion. Then you produce your double bond, change the place, and also the carbocation ion will change the place. And don't forget to label your uranium ion. So for this step, you will get 2 marks. 1 when you can show the 2 arrow, and the second mark will be given to you for this step when you're able to give all of the uranium ion. Step 3, which is removal of the H+. Proton is removed from the uranium ion to form the bromobenzene. Therefore, that I told you just now, FeBr4 minus come back, datang balik pada step yang terakhir. And then you must have 3 arrow here. From bond to bromine, from bromine to hydrogen, and then from bond to bond. We want to restore back the double bond in the benzene ring. So that's why we need the 3 arrow here to show the formation of the bromobenzene. You're able to show the 3 arrow will give you 1 mark. Then your product for this mechanism is bromobenzene together with FeBr3, which is your Lewis acid catalyst. At the end of the reaction, catalyst will be back as what we have initially. And then your byproduct for this mechanism is also HBr. Okay, settle for stage 1. Thank you.